Find the value of summation from 0 to infinity of 2 to the n plus 4 over 3 to the n. Okay, so this is a geometric series. The idea with a geometric series is you have a common ratio, an r, usually something that's below 1 that goes off to normally infinity, but not always, and not necessarily. So when you think geometric series, first thing that should pop in your head is a formula. And that formula should be n equals 1 to n. That's terrible. To the r equals, scooch over a little bit, 1 minus r to the n plus 1 all over 1 minus r. I'll change this to k just so it's a little bit more consistent. And so the idea here is you start from 0, you go to a value k of some value r to the n, and the end result for that is going to be 1 minus r to the k plus 1 all over 1 minus r. And so memorize this formula. One other good thing to memorize is that if you have 1/2 and k equals infinity, then the answer is going to be 2. So one of the most common geometric series you will see will be n equals 0 to infinity of 1/2 to the n. And that will equal 1 minus r to the k plus 1. What is this k? Over 1 minus r. So for 1/2, then this would be 1 minus 1/2 to the infinity, since n goes to infinity. Infinity plus 1 is the same as infinity. And that would be 0 all over 1 minus 1/2, which is 1 minus 1 over 1/2, which is 2. And it's good to kind of have that result in your head, because that way when you kind of get stuck and you forget the formula, you can at least remember what an answer to one specific value is going to be, and it might help you stumble through it in case you panic. Okay, so going back, rewrite this a little bit cleaner, a little bit nicer with green. So what we know is about a geometric series, n equals 0 to n equals, I'll say k. There we go. That's a much better, more formal way of doing it. R to the n equals 1 minus r to the k plus 1 all over 1 minus r. And you'll see different variations of this. I like to use this way of writing it because I think it's the cleanest, and it's most applicable to the most variations. So what we want to do is we want to make this look like this form. So we're going to rewrite this probably a couple times. So we'll do n equals 0 to infinity of 2 to the n plus 4 over 3 to the n, which equals, so we'll do 2/3 to the n plus, then we'll do another summation, and we can just separate the numerators. 4 times 1 over 3 to the n. Because what we can pretend is this 4 up here, so that's 4 times 1 to the n over 3 to the n. But 1 to the n is always just 1, so we can throw in that 1 to the n. And so what we have then is, move this over a little bit, and move this up, move the entire 4 out. So we just multiply the summation times 4. So we move the 4 to the outside of the summation. Blue. So now we got basically two geometric series that we're going to add together. And so for this one, we're going to have another key point to keep in mind is this n has to be 0 down here. If sometimes you'll see n equals 1 or n equals 2 or 3. A lot of times that'll be done just to make sure that you don't have 0 in the denominator. And you can take the summation and you can add in other single elements to kind of change that bottom. We don't have to do that here because it's 0 and that matches with our formula. So 0, 0. And then let's plug in our formula here. So 1 minus 2/3 to the infinity plus 1, so which I'll just call that infinity, round it off, over 1 minus 2/3 plus 4 times 1 minus 1/3 to the infinity plus 1, all over 1 minus 1/3. Yes. So change color to add emphasis and contrast. This goes to 0. This goes to 0. And we have 1 over 1/3. 1 minus 2/3 is 1/3. Plus 4 times 1 over 2/3. This gives us 3 plus 4 times 3/2. Which equals, let's see, cancel, equals 3 plus 2 times 3, which equals 3 plus 6, which equals 9. So the summation of all this is right here, 9. Oh, put it up here too, just to make sure. And that's how you do a geometric series. So when you see a geometric series, first thing you think of is this formula right here. Summation of n equals 0 to some value k. And you have some common ratio, usually a fraction that's less than 1. If it's greater than 1, then you try and plug it in, and you're going to get infinite number here. So r, ratio less than 1 to the power n, and that will equal 1 minus r to the k plus 1 all over 1 minus r. So if r happens to be greater than 1, like 2, then what you get is 1 minus 2 to the infinity, which completely destroys, you get negative infinity, therefore it won't work. Which makes sense, because if you have a 2 to the infinity and you add that up, you're going to get infinities. Diverges, if you will. Okay, so that's the idea behind a geometric series.